Hello and welcome to our lesson on how perpendicular lines can be represented with equations. Today, we will dive into an exciting topic that builds on your knowledge of linear equations and gradients, and it'll greatly enhance your understanding of algebra and geometric relationships. In this lesson, we'll explore the concept of perpendicular lines in more detail. We'll first investigate how the gradients of perpendicular lines relate to each other. Then, we will learn how to express this relationship through equations. Finally, we'll work through some examples to apply this new knowledge and solidify your understanding. Let's dive right into the concept of perpendicular lines and how they can be represented using equations. To begin with, let's recall that in our last lesson, we learned about parallel lines. We discovered that parallel lines have the same gradient because they run alongside each other without ever intersecting. Today, we will extend this idea to perpendicular lines. Gradients play a significant role in identifying whether two lines are perpendicular. Let's explore this with a simple example. Consider the equation of the line y equals x. What would the equation of a line perpendicular to this one look like? One example is y equals minus x. Looking at these two equations, you might think that determining the perpendicular line is simply a matter of negating the gradient. However, the process is not always this straightforward. Now let's take a different line, y equals 2x. Intuitively, the perpendicular shouldn't just be y equals minus 2x, because the line would be too steep. Therefore, we must do something more than just negating the gradient. Specifically, we need to take into account the steepness by modifying the coefficient of x. The trick is to take the reciprocal of the coefficient of x and then negate it. The reciprocal is essentially flipping the fraction. For 2 or 2 over 1, the reciprocal is 1 over 2. Then, negating it means we get minus 1 over 2, so the line perpendicular to y equals 2x would be y equals minus 1 over 2x. We don't need to prove why this works, just use the intuition that without this step, the perpendicular line would be too steep or shallow. Let's apply this technique to some worked examples to illustrate the process. Example 1. Consider the line y equals 3x plus 2. The gradient here is 3. The negative reciprocal of 3 is minus 1 over 3. Therefore, a line perpendicular to y equals 3x plus 2 would have a gradient of minus 1 over 3. For example, y equals minus 1 over 3x. Example 2. What about the equation 2y minus x equals 4? First, we need to rearrange this equation into the form y equals mx plus c so that we can identify the gradient. First, divide everything by 2. Y minus 1 over 2x equals 2. Then rearrange to make y the subject. Y equals 1 over 2x plus 2. The gradient is 1/2. The negative reciprocal of 1/2 is minus 2. Thus, a line perpendicular to 2y minus x equals 4 would have a gradient of minus 2. Example 3. Finally, consider 3y plus x equals 5. Here again, rearrange to isolate y. Subtract x from both sides and divide by 3. Y equals minus 1 over 3, x plus 5 over 3. The gradient is minus 1 over 3. The negative reciprocal of minus 1 over 3 is 3. So a line perpendicular to 3y plus x equals 5 would have a gradient of 3. By understanding and mastering these concepts, you can now describe and solve problems involving both parallel and perpendicular lines with equations. This is a powerful tool that bridges algebra and geometry, allowing us to explain the relationships we see in the geometric space through algebraic expressions. Let's start by examining the relationship between the gradients of perpendicular lines. Recall that if two lines are perpendicular, the product of their gradients, slopes, is minus 1. In other words, if the gradient of one line is am, then the gradient of the line perpendicular to it will be minus 1 over m. Example 1. Consider the line with equation y equals 2x plus 3. The gradient of this line is 2. Find the equation of the perpendicular line that passes through 1, 4. To find the equation of a line perpendicular to this one, we need a line with a gradient of minus 1 over 2. This means the line will be of the form y equals minus 1 over 2x plus c. Since the line passes through 1, 4, we can substitute those values in to find c. 4 equals minus 1 over 2 times 1 plus c. 4 plus 1 over 2 equals c. c equals 4.5. So, the equation of the line perpendicular to y equals 2x plus 3 and passing through 1, 4, is y equals minus 1 over 2x plus 4.5. Example 2. Consider a line with equation 2, y minus x equals minus 4. We want to find the equation of this perpendicular line that passes through the point, minus 1, 3. First, we need to rearrange to find the gradient. 2y equals x minus 4. y equals 1 over 2x minus 2. The gradient here is 1 over 2. Therefore, the gradient of a line perpendicular to this one would be minus 2. So it would be of the form y equals minus 2x plus c. Next, substitute minus 1, 3 to find c. 3 equals minus 2 times minus 1 plus c. 3 equals 2 plus c. c equals 1. Therefore, the equation of the line perpendicular to y equals 1 over 2x minus 2, and passing through minus 1, 3 is y equals minus 2x plus 1. By working through these examples, you've seen how to determine the equation of a line that is perpendicular to a given line and passes through a specific point. In today's lesson, we explored how perpendicular lines can be represented with equations, building on our understanding of gradients from previous lessons about parallel lines. We began by recognizing that while parallel lines share the same gradient, perpendicular lines have gradients that are negative reciprocals of each other. This means that if the gradient of one line is m, the gradient of a line perpendicular to it would be minus 1 per m. We applied this concept to various examples, rearranging equations to isolate y and identify the gradient. By taking the negative reciprocal of these gradients, we determined the equations of lines perpendicular to the given lines. This technique enables us to accurately describe and solve problems involving perpendicular relationships, bridging algebra and geometry. Through these examples, we reinforced the importance of understanding the relationship between gradients to effectively work with perpendicular lines in mathematical contexts. Watch the rest of the GCSE Maths course at Sophos Education.